Okay, welcome back everybody. I'm hoping I resolved the issues with the microphone, but I guess we will just have to wait and see. In fact, you probably won't even see this video if I haven't. Okay, so let's carry on here. The next topic is simplifying rational expressions. And I must say, I'm beginning to enjoy my work here. When life throws you curveballs, sometimes you need to adapt, and I'm happy that I'm learning a new skill here. Making YouTube videos in particular. You never know, this may come in handy at some point, and I might turn this into a business one day. Well, it's not my goal, but you never know what will happen, right? Okay, so let's begin here. I think first we'll look at a numerical example. So let's see what I've got in store for you guys. Okay, well, let's look at simplifying this fraction. Well, there's not much to it here. All we're really asking you to do is reduce this fraction. And how could we do that? Well, typically I see a lot of students write, oh, well, I can divide the top by 8 and I can divide the bottom by 8. But another way to do it is just to factor the numerator and denominator and cancel common factors. And this is going to be the same thing we do with rational expressions. So what does this look like? Well, I've got 16 can be written as 2 times 8, and 24 can be written as 3 times 8. And then I can cancel the 8's because 8 divided by 8 is 1. And I'm left with 2/3. And I'm trying to figure out why my camera is not shading the right-hand side of this piece of paper in the same way. Let me see if I can just make a quick adjustment here. Well, it's just one problem after another, isn't it? Okay, let's try this. Oh, now it's looking kind of late in the middle. Okay, well, hopefully you can see what's going on there, and we can just continue on. Pardon me. Okay, so let's try this with a rational expression. I'm just going to start with a very basic one because it's going to lead us into some other topics here. So let's look at this. Let's simplify x minus 2 divided by x minus 2. Alright, well, there's really not much to it. If you observe, no matter which value of x we stick in here, this rational expression is almost always going to evaluate to 1. For example, if I put in x equals 3, I'll get 3 minus 2 over 3 minus 2, which is 1 over 1, which equals 1. So what can we do here? Well, in fact, we know that x minus 2 and x minus 2, these are common factors in the numerator and denominator, and so we can cancel them out just like we did up here and say that this is equal to 1. Okay, now there's one small little detail we have to pay attention to here. There's a value of x here that when we substitute it into this expression, we get 0 over 0, which will give us an undefined value for our expression. And you can kind of just see by inspection, if I put in 2, I get 2 minus 2 over 2 minus 2, which is 0 over 0, which is undefined. So it is true that this always equals 1, except when x is equal to 2. So this is actually a domain restriction here. And I can say this, x is not equal to 2. Yeah, that's our domain. And from our last video, you could also write this in set notation, but I'm not going to do that in this example. Okay? All right, so next, let's look at simplifying a more complex rational expression. Okay, let's simplify and state the domain of 2x plus 3 over 4x squared plus 12x plus 9. Okay, now the reason I wanted to do this question was I wanted you guys to have a chance to get used to my presentation, but in particular, I want you guys to see how to factor this. We haven't done anything with the factoring checklist yet for those of you that aren't in my class. So at some point I'm going to work the factoring checklist into one of these lessons, but I just wanted to make sure that everybody from Mo and Gitu's class is on the same page. So anyhow, so what do we need to do here? Well, observe in the first example we did, we factored the numerator and denominator, and that allowed us to cancel common factors. So all we need to do here to simplify this rational expression is simply factor the numerator and denominator. The numerator is already a linear factor, so it's already factored. All we need to do is factor the denominator now. Alright, so maybe we can just do this off to the side. If I factor the denominator, we've got a trinomial that will factor with decomposition, and we're looking for something that multiplies to 4 times 9 and adds to 12. So we're looking for something that multiplies to 8 times c. 4 times 9 is 36, and it needs to add to 12. And in this case, we can just see that 6 times 6, 6 plus 6. And so we can do the decomposition on the denominator here. What do we get? We've got 4x squared plus 12x plus 9 equals 4x squared plus 6x plus 6x plus 9. All right, we just decompose the 12x like so. And now we've got 4 terms, and this is a groupable expression. In other words, we can factor it by grouping now. All right, so looking at the first 2 terms, I can see my GCF is 2x. And then looking at these last 2 terms, I can see my GCF here is plus 3. So I'll factor a 2x out of the first 2 terms. And then I'll factor a plus 3 out of the second 2 terms. And now we've got the new GCF of 2x plus 3, which we can factor out. And that leaves behind a 2x plus 3 as our second factor, like so. Okay, so what do we have here for our whole expression? Well, we've got 2x plus 3 over 4x squared plus 12x plus 9 is equal to 2x plus 3 over 2x plus 3 times 2x plus 3. All right, and now we can cancel a common factor of 2x plus 3, 2x plus 3, just 1 for 1. And we're just left with 1 over 2x plus 3. And that's our simplified form here. Okay, a few comments here. We need to look for domain restrictions. Now, when you're doing these questions, just look at each of the fractions in every step, at least each of the fractions that have a factored form to them. Okay, and when you look at them, just look for the zeros in the denominator. Okay, so in the last lesson we looked at the domain. We set the denominator equal to 0 and solved, but in this case, we've already got the factored form. We can kind of just do it by inspection here. I can see if 2x plus 3 equals 0, then I'll have division by 0. Okay, and actually, for those of you that aren't comfortable with these types where the leading coefficient isn't 1, well, what you can do is just set the whole factor to 0. All right, I want this to equal 0. And then now you're just left with a simple linear equation to solve. Okay, I've got 2x plus 3 equals 0. I'm just going to minus 3 from both sides. And then divide by 2. And that gives me x equals minus 3 over 2. And of course, just like in the last video, we have to say that x cannot equal negative 3 over 2 because that will give us division by 0. Okay, all right, so that's that example. What I'm going to suggest here is to pause the video for a second. Sorry, the lighting is really odd here. I'm not sure why this is happening, but it seems pretty legible, honestly. So, okay, anyhow, maybe pause the video here and do the U-try on page 278. Okay, so carrying on here, the next thing we want to look at is additive inverses. So additive inverses. This definition can be found on page 279 in the textbook. And I'm just going to kind of restate it here. Okay, so two objects are called additive inverses if they add to 0, add or sum. I much prefer using the word sum. Okay, so for example, 3 and minus 3 are additive inverses for obvious reasons, since they add to 0. Okay, now, next, what are the properties of these additive inverses? Well, I'm sure there's many properties, but one in particular that we want to pay attention to is this. When dividing an object by its additive inverse, the result is minus 1. And we'll just use the same example as above. For example, 3 divided by minus 3 equals -1. Okay, so what does this look like when we're doing algebra? Well, it just simply looks like this. Okay, so just move this up. Okay, so actually I'm just gonna swap out my pencil here. It's getting a bit dull. Okay, so when we're doing algebra, in algebra, a minus b and b minus a are additive inverses. And so let's see why. Well, observe b minus c divide, b minus a, sorry, a little typo there, divided by a minus b. Well, I can factor a -1 out of the numerator here, which leaves me with this. And now, a minus b divided by a minus b, this is always equal to 1, so we can just cancel them out, and our result is just -1. Okay, and I'm just going to grab my piece of paper from one of the first examples that we did. This is why I showed you this example here. When we divided x minus 2 by x minus 2, the answer was always 1. Well, what do we have here? No matter which value of a and b I substitute in here, this piece here is always going to equal 1. -1 times 1 is obviously -1. Anything else I should say here? Well, I guess we should say that a cannot equal b. If a and b are the same, then we'll get division by 0. Just a little extra little thing to consider here. Okay, so let's do the last example of this lesson, then I'll set you up with some homework, and we'll move on to our next topic, which is multiplying and dividing rational expressions. Of course, we'll start that in the next video. Actually, I'm just going to start on a whole new page. All right, example. Let's simplify and find the domain of x squared minus 2x plus 1 over 1 minus x squared. Okay, here's what we need to do here. Just factor the numerator and denominator. Remember, let's not lose sight of what we're doing here. We're just trying to simplify these things by canceling common factors. And if I factor the numerator and denominator, well, let's start on the denominator. What do we have? We've got 1 minus x squared in the denominator, which factors as a difference of squares. 1 minus x times 1 plus x, like so. Okay, and then in the numerator, this is the more simple type of trinomials. I'm just looking for something that adds to -2 and multiplies to +1. Looking for something that multiplies to -1. Sorry, I usually do the multiplication above, multiplies to +1, and then adds to -2. And in this case, it's -1 and -1. And with these more simple types, once you see this, you know exactly how to factor it. You just use these numbers in the factorization. and we just get x minus 1 times x minus 1. Okay, now if you don't feel comfortable just doing these ones by inspection, then of course you can always use the decomposition on this as well. Okay, now if you notice, we've got two additive inverses here. Okay, so what we can do is just factor a negative out of here and then cancels these out. But the whole point in showing you guys what additive inverses do is so that we didn't have to write so many steps, because we're lazy as math people. So once we see this, we know we can just cancel like so. But when I cancel that, I'm left with a minus 1, which I'll just stick at the very front. And then on the top, we're left with x minus 1 and 1 plus x. Well, 1 plus x is the same as x plus 1. And that's our final answer. Okay, now we just have to look at domain restrictions. And again, if you think back to that first example that we did, we had x minus 2 divided by x minus 2 equals 1. Now, in that example, what I said was, okay, well, wait a minute here. X minus 2 divided by x minus 2 always equals 1, except in one very special situation, when x equals 2. That gave us division by 0. Okay, so when we do the domain restrictions here, we actually have to look at this canceled factor here and include it in our domain restrictions. Okay, so what do we get? Well, from this factor here, we know that x cannot equal minus 1. And then from this factor here, we can see that x cannot equal plus 1. And all in all, this gives us our domain. X is any real number such that, again, that's what that vertical line means, such that x is not equal to plus or minus 1. Okay, so that pretty much concludes this lesson. Thankfully, I'm pretty sure all 3 sections have completed this in class, so I don't feel too bad. We'll try to go a bit more detail into some of the more difficult topics, but in the event that you haven't worked your way through this chapter yet, you should do the U-try. On page 280. And then for homework, Duke the dog has just come up. He might start barking at me in a second. Okay, I'm just going to rush through this. Okay, and then homework, for homework, do pages 281 to 282. Okay, good. I'm signing off here, and I will see you guys for the next video.